Hello, everyone. I'm Dr. Aziza Bakouche. I'm here in the studio joined by Dr. Greg Jenkins. Welcome to another edition of At Howard. Welcome, Dr. Jenkins, to the program.
Thank you.
Let's first start off by talking a bit about hurricanes and the research that you've been involved in. What is a hurricane and how do hurricanes form?
Well, in the broadest sense, a hurricane is an organized tropical disturbance whose origin is mostly West Africa. It basically occurs during the months of June and November, although we can have hurricanes even outside of that period. One of the main ingredients would be warm water. So in general, the water must be 80 degrees Fahrenheit or warmer, and this obviously only occurs in the tropics. A hurricane goes through various stages. So the first stage is a tropical wave. Again, these tropical waves are often found to come across West Africa every 3 to 5 days on average. They then move into a stage called tropical depression, tropical storm. Once we get to the tropical storm stage, it has a name, and then finally hurricane. There are 5 categories, Category 1 being the weakest and Category 5 being the strongest and generally most devastating type of hurricane.
You've been studying Saharan dust particles in Senegal during your expedition time. Can you talk a bit more about these particles and what role do they play in hurricane formation?
Well, this is an open area of research. There are basically 2 schools of thought out there. But first, let me get to the Saharan dust. Literally, billions of tons of Saharan dust come off the African continent every year. In general, this air is dry and very stable. This is not what hurricanes like to thrive in. So hurricanes need organized thunderstorms. This air is very disruptive in general. However, at the same time, the particles of dust can serve as cloud condensation nuclei or ice nuclei. This is the first origin of the raindrop. We're unclear about what role it plays. We've seen times when we get these big dust storms and it's just so disruptive. The storm is pretty much wiped out in a day. At the same time, we've seen in 2006, NASA actually had a field expedition in West Africa and Cape Verde. We saw evidence of storms actually getting stronger when we had dust outbreaks. The science question is not yet resolved. And that's in part why we keep doing missions, because we really want to know. But I would say it's an unresolved question.
What is it like being in one of these Saharan dust storms?
Last summer, during the mission, we were in Cape Verde and in Senegal, and we have a number of instruments on the ground. We happened to encounter a very huge dust storm on approximately July the 7th. There was so much dust in the atmosphere, the sun looked like it was just a disk. You could look directly at it. Someone from Senegal said, "Is that the moon or is that the sun?" I said, "It's the sun, but there's a lot of dust above us."
The National Science Foundation, NSF, NOAA, and NASA have been responsible for putting together these expeditions. Can you talk briefly about the overall scientific purpose or objective of these expeditions?
The biggest uncertainty that we have about hurricanes is intensity and genesis. Okay, so we get these waves coming off Africa every 3 to 5 days, but only 1 in 10 will become a hurricane. Now, which one is it? That's the question. And generally between August 1st and let's say September the 15th, we might see 1 in 3 of these waves actually become hurricanes or a tropical storm. So the question is genesis. Which of these waves, or if it's not a wave, you have the right conditions where you bring together all the ingredients, is going to form a tropical, depression or ultimately a hurricane. The other one is intensity. Our forecasts are very poor at doing intensity. So in 2005, Hurricane Katrina, for example, exploded from basically a Category 1 to a Category 5 storm in a matter of days. The models were very poor at being able to predict that kind of intensification. And part of the reason is that there are both large-scale external forcing that control if the hurricane is going to weaken or strengthen, for example, dry air, or if there's a lot of wind shear. So these are these external forcings. And then there's these internal processes that we know very little about. What's going on inside of the hurricane? So you got to send airplanes in there. And that was the whole point. So this summer, NSF sent their high performance jet, which flies at about 50,000 feet, to investigate this question of which storms will become hurricanes. So they were interested in Genesis. NASA had 3 aircraft, the DC-8, which is a big laboratory with all kinds of instruments on it. There was an ER-2 aircraft, which flies high above the storm. And finally, this new technology, the Global Hawk. And we know Global Hawks are generally used in wartime and places far away from here. But this was the first time that a Global Hawk flew above a hurricane. And the advantage is that these aircrafts, the Global Hawk, can stay above a storm for 30 hours. You can't do that with normal aircraft because there are limitations that the pilots have, and also the science team. They're worn out after flying for 8 hours, and then you've got fuel constraints. So that was a very interesting deployment, you know, this non-human aircraft that was being controlled from Dryden Air Force Base in California. Very interesting. And then NOAA had their aircraft. So they had these planes called P-3s, and then they also had this high-performance G-force that flies at 50,000 feet. All of these aircraft were flying around the hurricane. At times, there were 5 or 6 aircraft at different altitudes in different parts of the storms. And of course, we've got the Air Force hurricane hunters. They have to fly in and report back how strong these storms are to the National Hurricane Center. So it was an amazing set of experiments to answer these questions. You know, we still don't know the answer yet. We're poring over this data. Just let me tell you one thing. We still don't know, for example, if you have to have a pre-existing disturbance, for example, one of these disturbances from Africa, or is it possible to have an area where you just have thunderstorms going for 6, 8, 10, 12 hours? This is what we call the bottom-up process. So the bottom-up process, that's a hypothesis. We wanted to see if that happened. And then there's the top-down process where we have these disturbances at about 10,000 feet. And somehow the energy goes down to the surface and we get this rotating system, which becomes a hurricane.
How has your research connected with the objectives of the expedition?
So this is an interesting question because the aircraft this summer were deployed in the Caribbean. So we had aircraft in St. Croix, we had aircraft in Fort Lauderdale, and there was also deployments from Barbados. Now, we were the ground team, but we were the ground team covering 3,000 or 4,000 kilometers of distance. So we had teams in Barbados, Cape Verde, and Senegal. And we would launch balloons because from this data, when we launch the balloons, we can actually see when these disturbances are going past us. In addition, we were looking at chemistry. So hurricanes can produce a lot of lightning, and lightning has the ability to produce ozone through a series of reactions. We were actually interested in wondering, is ozone being produced when we have a hurricane? And then we also examined the Saharan air layer. So we tracked these big dust outbreaks from Cape Verde down to Barbados, and we looked at how did the air change chemically, thermodynamically, dynamically.
Can you talk a little bit about science, technology, engineering, and math, STEM, the fact that there's a need for increasing the participation of underrepresented groups, and to include in particular African Americans in these fields? How do we go about doing that? What's the best way to increase these numbers?
Well, the numbers are dismal. In general, we're talking about 1, 2, or 3% of African Americans being in many of the physical sciences. There has been a big push to make that happen, but you know, it really must happen at all levels, from primary school all the way through to university. It's almost like we've got to protect these precious young minds all the way through the system. there are a lot of forces out there, especially in middle school, where somehow the kids become less interested in science and math. And so we have a serious challenge in terms of keeping them inspired, staying behind them, telling them, hey, you're doing a great job, and getting them all the way through to the point of being professionals. This is definitely not an easy task. But I think we all are role models in one way or another. So as a professor, I'm a role model. I've got to be positive, but parents have to do the same thing, okay? And actually students have to be positive role models to each other.
Can you talk to us a little bit about the student involvement in these expeditions?
For the students, great experience. And the reason why it's a great experience is that it's all real. It's real time. We were out in the field all day. At times we took measurements at 3 in the morning, 6 in the morning. We were sending this data up to the aircraft teams and to the National Hurricane Center. So they were there right at the front lines. The students in Cape Verde and in Barbados, we're communicating thousands of miles through Skype or email, and they've got a job to do. And sometimes it's like, I need you to change up. I need you to do this tomorrow, today, go to bed early. So the students get great experience. In addition, the whole science team, big science teams from NASA and NSF and NOAA, these students are sitting in those briefings. And then some of our students are going on the aircraft. We had a number of students who actually flew into the hurricanes. That is a great experience. It's not just a great experience for their research or their dissertation or thesis, but it's a great story for them to tell their families, their friends, and one day their kids to say, I flew into this Category 4 hurricane. So I think that's part of the solution in terms of getting more kids into STEM, just to let them know how exciting it is, and then for them to contribute, to say, wow, I did that.
Absolutely. Can you talk a little bit more about the impact or how this research is ultimately going to connect with the human experience, or how does it connect with people at the end of the day?
So we know about the physical aspects of hurricanes, but hurricanes are the deadliest and most damaging form of natural hazard to occur on an annual basis. When we look at Hurricane Katrina, 100 billion, 200 billion in damage, lives lost, thousands. And the real part about this is, how do we protect vulnerable people? So we can do the best forecast in the world, but if people cannot evacuate because they don't have the resources, the cars, if we don't take care of grandma who cannot get out, needs more time, or the disabled who need more help, I mean, that's why we have disasters. That's why this is so important. That's why we need students of color engaged here, because at some point in time, they get it. They understand what the situation is. Sometimes mainstream model doesn't always work. And we saw that with Katrina. We have Haiti, a situation where the people are tremendously vulnerable, where 1 million people are still living in tents. We got to connect. We got to think about those who are vulnerable. So the science carries us so far, but at the end of the day, it's all about the human experience. It's all about livelihoods and keeping, folks together through these kinds of hazards. And it's very serious because there are other things that are happening. For example, we know the entire climate system is warming. Oceans are warming. The oceans are the fuel for hurricanes. Hurricanes will get stronger in the future, more than likely. Our science has not been able to show that conclusively, but everything that we know about hurricanes say they will get stronger. In addition, far, far away, the Greenland ice sheet melting rapidly. What's that going to do? It's going to raise up sea level. So folks who live in places like Barbados, hey, they're right there on the coast. So the sea level is going to rise, land's going to be removed, these storms are going to be stronger, and when the surge of water comes in, it's going to cause a lot more damage. So there is a lot to think about, a lot to worry about. And there are a lot of people who, well, If a disaster happens, we see it then. But we need to be preparing folks for this. That's the human connection part we really have to just address. We have to know that there are vulnerable people out there, and we have to be prepared to deal with them. I think Katrina should have given us enough, but I don't think it has. And not only that, some of the problems that we're talking about are not physical. They're just changing. So, big cities like Houston, 4 or 5 million people. Can you evacuate 4 or 5 million people in 72 hours? Our science is not good enough yet to say, we know where this hurricane is going to make landfall in 96 hours. So the awareness has to be there. You have to evacuate 4 or 5 million people. And unfortunately, in this country, I taught a course last semester, or last year, and we looked at the demographics. And you see race, you see poverty, you see all these factors in a very segregated way in many big cities, from Charleston to Wilmington, Houston, New Orleans, Miami, all of the places that are vulnerable. And I mean, it's not just the hurricane hits, but then people have got to be resilient and come away from that. So the problems are really serious, and this is not one discipline that can deal with this. You got to have the social sciences in this. If Facebook is how young folks are communicating, maybe the hurricane warnings and watches need to go out over Facebook. So then they can tell each other and they can tell their parents. And they can say, okay, we got to get out.
This past September, I went with Dr. Jenkins to film a documentary called Over the Hurricane, which basically features the research work of a group of scientists from NASA, from NOAA, and from NSF, the National Science Foundation. And this particular film, the objective of the film is really to increase awareness about hurricanes, but also to try to use the film to increase the participation and interest of underserved groups, particularly African Americans, in the fields of science, technology, engineering, and math, STEM-related fields.
It was unspeakable. I mean, where we thought that there was land, there was water. You could only see the tops of the roof.
Hurricanes like Hurricane Katrina that struck New Orleans in 2005 are among the deadliest forces of nature. Katrina was a Category 5 hurricane with winds approaching speeds of 155 miles per hour while over the Gulf of Mexico. It left behind a trail of devastation of inconceivable magnitude.
Seeing the devastation was just unspeakable. It took my breath away that storms like this can create unsurmountable amount of damage.
With its tremendous force, it catapulted the Gulf Stream waters to nearly 30 feet in height, causing the levee to fail in a major way.
You know, you're looking at 25% and more of the population not having access to cars. More than 25% being in poverty.
I never been like this in my life.
That really brought what I do and what the people on the aircraft, it brought it to a different level.
Now scientists from NASA and from NOAA are about to embark on an ambitious scientific expedition right through the eye of some of the most powerful hurricanes. Using NASA Global Position satellites and other cutting-edge technologies, this team of scientists hopes to unveil these mysteries while traveling through the eye of hurricanes.
While it's important to know how these hazards work, that human component is really the critical piece.
Dr. Jenkins, I wanted to see if you could comment a little bit more about the issue of participation of African Americans in science? What are we dealing with? What are we facing?
Well, again, we know the numbers are very low. And the importance of this documentary, in my opinion, is that we take it to people's living rooms. They see right there what it's like to fly into a hurricane. But for those students of color, they see people who are like them working on these aircraft. They get a real sense when we were in Barbados, when we were talking to folks in emergency management, what they're doing. They see what was going on at the Caribbean Institute of Met and Hydrology, where there was so much diversity, and both gender and racial diversity. They see those role models right there. But I really think the interesting thing is this technology and knowing, you know, we haven't solved all the problems with hurricanes. There's a lot to be learned. And we need the young people, in fact, to step up, to come into these areas. Hey, all you got to do is watch the documentary, and you'll come away from that with a lot of ideas and probably more questions than answers, because that's what we came away with. We were wondering ourselves, why did this happen? Okay, that's where the science comes in. We'll be working through that for the next few years, really trying to make sense of all of this. But I think the most important thing about the documentary is that you get out to people's living rooms so they see it live.
Exactly, and then the students also get an understanding of how to get involved and how can situations like Katrina, for example, be avoided.
That's right.
In the future through doing this type of research.
And one other thing was that we asked most of the scientists, how'd you get interested in this? How'd you start out? What do you need to take? Math, physics, science? And we heard a whole variety of answers. And that's really what this is all about. Taking the mystery out of it and saying, these are the concrete steps. And if you want to do it, this is what you need to do.
Dr. Jenkins, can you talk to us a little bit about the last hurricane season? What was specifically interesting or distinct about the season?
Well, in one sense, NOAA called it a gentle giant. There were 19 named storms. Now, this is well above normal. So the normal number of named storms are about 10. So we were at 19. It was gentle because really there was not much impact on the United States. But if you lived in the Caribbean, St. Lucia or Barbados, they got hit by Hurricane Tomás. If you were in Mexico, Hurricane Carl. So it really did depend on your perspective. There were a number of major hurricanes. When I say major, I mean category 3, 4, or 5. So though there were strong storms out there, we were lucky in a sense that they all tended to turn out towards the north, away from land. Hurricane Earl, we were worried about that because it paralleled the eastern U.S., east coast of the U.S. There was a lot of uncertainty as to whether it was going to hit the U.S. It did have some impact on Bermuda. So it was an above normal season as compared to what we normally expect. But this is a part of a longer term trend. Since 1995, we've seen more hurricanes than normal. The only exception is El Nino years, and they happen every 3 or 4 years, where we see a lot of wind shear, which tends to take the storms apart. But it appears that we are in a new cycle of intense hurricanes, and actually more frequent hurricanes. Again, starting in about 1995, we saw the numbers go up rapidly. In 2005, when Hurricane Katrina hit New Orleans, there were 27 or 28 named storms. This has never happened before. There are two potential hypotheses out there. One, that we see normal cycles of more frequent and possibly intense hurricanes every 30, 40, 50 years. Okay, so the 1940s and 50s, hurricanes were very active. And then in the 1990s, this cycle seems to have come back. Now, unfortunately, the data only goes back 150 years. So we don't know if this is true or not, but the cycles tend to last about 30 to 40 years. So we would be, if this is correct, based on that hypothesis, entering into a cycle of more frequent hurricanes and probably stronger for the next 30 or so years. The other one is global warming, because the ocean temperatures are warming. And that could be, in fact, the reason why the number of storms have gone up. Or it could be some combination of both, where we have a natural cycle, plus we as humans are directly influencing the climate, making it more conducive to produce more hurricanes and stronger hurricanes. But once again, the verdict is out on that. We don't know what the answer is. But we just have to be vigilant and be aware that we are moving into what's most likely a more frequent and more intense period of hurricanes.
Thank you so much, Dr. Jenkins, for joining us here at Howard. Thanks so much for watching, everyone.